This is question 16 from section 2 of the 2009 BMAT, and in this question we're asked to evaluate this expression involving a square root of a fraction with various numbers inside. So if you want to have a go at this question yourself, pause the video now. Okay, so I think the first thing to notice is, what have we got? We've got 4 numbers here, 2 on the top and 2 on the bottom, and 3 of those are in standard form. They're a number times the power of 10, and then the other one is this. So probably it's going to be easiest if we can convert this into standard form as well, because that will make it easier to add to and multiply and divide by and square root when all the other numbers are in standard form. So let's try to get this in standard form first. So that's our problem, and if I'm trying to get it in standard form, what does that mean? Well, I want it to be a number times the power of 10. And the easiest way to do that, so we can see this is a fraction and it's going to be less than 1. So I'm probably going to have a negative power of 10. So what I'm expecting is to get this equal to some number over some power of 10. And that means I really want a power of 10 on the bottom. So how can I get that? Well, what we might notice here is that 25 times 4 is 100. So if we multiply top and bottom by 4, then the bottom becomes a power of 10. So let's do that, and we get 4 over, let's see, we have 4 times 25 is 100 and two more zeros, so that's 10,000. And 4 over 10,000 is 4 over 10 to the 4, which is the same as 4 times 10 to the minus 4. So 10 to the minus 4 basically just means we have a power of 10 with 4 zeros on the bottom. Okay, so next we need to simplify this fraction before we can square root it. But to simplify the fraction, we first need to simplify the top and the bottom, because we can divide one number by another number. It's harder to divide a sum by another sum unless you simplify. So let's think about what the top and the bottom both come to. So if we look at the bottom, this part we just said is 4 times 10 to the minus 4, and this is 3 times 10 to the minus 4. So because the power of 10s, the powers of 10 are the same, that makes it much easier to add. Whereas at the top we've got sometimes 10 to the 3 plus something times 10 to the 2. So if we imagine writing these out as just two numbers in decimal form, they're going to have different numbers of zeros. So we need to be different numbers of zeros, so we're going to need to be careful in adding them. So let's look at the bottom first because it's easier. And the bottom is, well, this is 4 times 10 to the minus 4, this is 3 times 10 to the minus 4, and that means we can just add the number parts, so we get 7 times 10 to the minus 4. You could think of this as taking out 10 to the minus 4 as a common factor. Whereas on the top, okay, we need to be a bit more careful. So what I'm going to do is write it as 20 times 10 squared plus 8 times 10 squared, instead of 2 times 10 cubed as it is in the question. And that's because now I can take out my 10 squared as a common factor, and then the numbers just add up and give me 28. And this isn't in standard form anymore. I could convert it back by dividing by 10 again. So dividing by 10 here and increasing the power of 10 here. Alternatively, I could have made this 2 times 10 cubed and 0.8 times 10 cubed to do the same thing. But we are going to divide in a second, so it's probably easier to keep it in whole numbers for now. So another way you could have done this is, instead of writing these in standard form, to just write them out. So we had 20 times 10 squared, or 2 times 10 cubed, which is just 2,000, and then this is 800, and we could just add those together to make 2,800, and leave it like that, because we're about to do another operation anyway, so there's no point changing it back into standard form. So let's just note what we've done. We started off with this expression, and now we've simplified the top and the bottom, so the top is this and the bottom is this. So we just need to do this division and then square root. So we can actually make this division easy for ourselves. Can you see how to do that? Well, firstly we can think about the numbers and then the powers of 10. So the numbers 28, you might recognise it. It's a multiple of 7, and we've got a 7 on the bottom as well. So that means we can cancel, and 28 is 4 times 7, so we just get a 4 and then cancel. And then the powers of 10, so what do we need to know here? We need to know if you divide a power of 10 by a power of 10, then the powers subtract, so I get this minus this. And that's 2 minus minus 4, which becomes plus 6. So that means inside my square root I now have 4 times 10 to the 6. So can you see how to square root this? Well, the nice thing about having a square root of a product of two things is you can square root the two things separately. So 4, we know the square root of that is 2, and if you square root a power of 10, you just halve the power. So that means we end up with 2 times 10 to the power of a half of 6, which is 3. And then finally, the answers aren't actually given in standard form. We need to actually multiply this out, but this just means 3 zeros. So we have 2 followed by 3 zeros, which is 2000, and that is option F.